Hello everyone. Today I'm going to show you examples how to find your empirical formula and then eventually how to find the molecular formula. In my last video I gave an idea about the molecular formula and empirical formula. This is how we find empirical formula and molecular formula. So molecular formula is equal to, I'm writing in just the letters, empirical formula times n is as a subscript, n is equal to, obviously if you want to find the molecular formula you need first empirical formula as well as n. So n will be equal to molecular mass, sometimes we use the word molar mass, divided by empirical formula mass. This is very important because if you will use the word empirical formula, then sometimes kids they are confused. So yeah, so better use empirical form. This is my table for empirical formula, and I have a question for you to save my time. Let's read the question. A specialized stimulant used in the research is found to have 49.48 gram of carbon and 5.19 gram of hydrogen, 28.85 gram of nitrogen, and 16.48 gram of oxygen. And through mass spectrometry, its molar mass is given to you. That is equal to 194.19. In my last video, I mentioned that it's better to tell your kids that molar mass is always given to you in the question, so that they are not confused that molar mass and the individual element mass are the same one. So let's go back to our question, and I'm going to show you how to find molecular formula, but first how to use the empirical formula. Here we go. So 6 columns. In the first column, you have to write the element symbol. So in the question, it's clear we have total 4 different elements. So I have carbon, I have hydrogen, I have nitrogen, I have oxygen. And in the second column, atomic mass, standard mass from the periodic table. So I will say use the whole value. 12 grams for carbon, hydrogen 1 gram, nitrogen 14 gram, oxygen 16 gram. And in the third column, sometimes their amount is given in terms of percentage, sometimes it's the maths. So I use the fill letters too, so that we have a formula. It's lowercase m and the standard mass is the uppercase m. So it's clear that carbon is 49.48 gram, hydrogen 5.19 gram, 28.85 gram nitrogen, and 60.48 gram of oxygen. So I will write down the values here. This is 49.48 grams, hydrogen is 5.19 grams, and nitrogen is 28.85 grams, and oxygen is 16.48 grams. So in my fourth column, so we need to find the number of moles. It's clear in this column that formula is small m divided by your capital M. And for carbon, we will write 49.48 divided by 12, and then we will write for hydrogen 5.19 divided by 1, and for nitrogen this is 28.85 divided by 14. For oxygen this is 16.48 divided by 16. This is our main column, because usually kids, they can do 4 columns, but they actually sometime lost in the 5th column. So this is a tricky one. So here I will write down the number of moles. I mentioned here simplest atomic ratio by dividing the smallest number of moles with the rest of the moles. So we will write the number of moles here. So for my carbon, my number of mole is 4.12. For hydrogen, anything divided with the 1 is same number. For nitrogen, it's 2.06. For oxygen, this is 1.03. Yeah, for say for the time, I already did my calculation. So then you need to ask your kids, okay, which one is the smallest one? So I will say circle it. Then it's easy to find. Otherwise, they will start dividing everything together. So this is the smallest one. So the smallest number of moles will divide with rest of the number of moles. So 1.03 will divide with rest of the number of moles. Obviously, it will divide with itself 2. Here we go. If we have a whole number, we are lucky. If we don't have whole number, then we have to do some modification. Here we go. So this is my simplest ratio. So it means my empirical formula is, I'm going to show you the formula because eventually we need to find the molecular formula. First, empirical formula. So empirical formula is carbon 4 as a subscript, hydrogen is 5, nitrogen is 2, oxygen is 1. We can check parallel. You can see carbon 4, hydrogen 5, nitrogen 2, oxygen 1. This is our simplest ratio. So, but the question is, what's the molecular formula? Sometimes question is not direct, that find molecular formula. So one thing you can tell your kids, if standard molar mass is given to you, it means your final question is about molecular formula. You are not going to stop till empirical formula. So we need to find our molecular formula. But for that, I need N. For N, I need empirical formula mass. So it means we need to do the calculation here to find the empirical formula mass. There we go. So we have 4. Same thing like you do calculations for your molecular mass. Hydrogen 1. We are multiplying the subscript with their standard atomic mass. 2 times 14, which is already in your table. You can tell your kids you don't have to go back to the periodic table. So this is 48 plus 5. 14 times 2 is 28 plus 16. So total empirical mass is my 97. Here we go. So, and where is my molar mass? Molar mass is 194. 194.19, and your empirical mass is 97. What is your N value? 2. Let's make your molecular formula. Here we go. I'm gonna write here. So empirical formula is C₄H₅. Sorry, this is H5N₂O1, and my N is 2. So here you need to multiply everything inside the bracket. So my molecular formula will be equal to 2 times 4 will be 8, 5 times 2 will be 10, 2 times 2 will be 4, 1 times 2, 2. This is actually, by the way, formula of actual caffeine. You can tell your kids too. So this is one example. I'm going to show you one more example. And yeah, let's make some space. Here we go. Okay, second question, one more example. So it's not difficult if you will use the table, then it's easy to understand, do the calculation. Okay, here we go. Erase it as everything. The next question is, a complex catalyst used in the industrial synthesis analyzed. It contained 43.38 gram of platinum, 23.59 gram of chlorine, and 33.03 gram of xenon. And its experimental molar mass is 899.4 gram per mole. So it looks like in this question we have three different elements. So their mass is given to you in grams, molar mass is given to you. So it means we have to find their molecular formula. So same thing, we will write down their symbols in the first column. So it's platinum, then you have a chlorine, then we have a xenon. Their atomic mass from the periodic table, use the round figure please, 195 for platinum, 35 for chlorine, xenon is 131, and their masses are given to you in the question, 43.38 grams, chlorine is 23.59, and xenon is 33.03. Then we have to find the number of moles, 43.38 divided by 195, which is equal to 0.2224. And for chlorine, it's 23.59 divided by 35, which is equal to 0.6740. And for xenon, it's 33.03 divided by 131, that is equal to 0.2521. So then you can ask your question, which one is the smallest one? So this is one, by the way. I will write it down again. 2521. So this is our smallest one. You will divide the smallest number of mole with the rest of the number of moles. Obviously, it will divide with itself. I will use the different color. 0.224, which is equal to 1. 0.224, which is equal to 3. So it's a whole number. 0.224. This is 1.1. So 1.1, this is one modification. If after decimal it's 1, that is equal to 1. I will show you the modification at the end. So based on these number of moles, what is my empirical formula? My empirical formula is platinum number 1, chlorine 3, xenon is 1. There we go. Xenon is 1. So, but we have to find their molar mass, molecular formula. Sorry. So I will say first find the empirical formula mass from the empirical formula, which is platinum 1, chlorine 3, xenon 1. So 1 time platinum atomic mass is 195 plus 3 times 35 atomic mass plus xenon is 1 time 131. So total empirical formula mass is equal to 431. Okay, so then for n value, we need to check what is our molar mass. That is 899.4, and empirical mass is 431, which is equal to 0. So now what is my molecular formula? Empirical formula: platinum 1, chlorine 3, xenon 1, N is 2, which will become platinum 2, Cl6, xenon 2. There we go. So yes, This is how we do the calculations to find the empirical formula and then eventually the molecular formula. So yes, for modification for your fifth column, I want to show you one thing. uh, let's say your student have this, your fifth column has these values 1.2. Now after decimal it's 2, you cannot just use the 1 here, we need to modification. So for here your kids need to multiply starting with the 2 till 9, then so that they have a 0 after decimal, because atoms they don't combine in fractional decimal, it should be whole number. Or if 0 is not possible because sometimes we have odd number, then after decimal it should be 9. So 9 means we directly round up to the next number. So here I will start multiplying with the 2. Okay, if I multiply with the 2, my answer is 2.4. It's still not 0, it's 4. So I will go to the next number. Next is 3. So the next, if I multiply with the 3, this is 3.6. After decimal, it's again 6. No, I cannot use the 3 also. So then I will go to the next number. If I multiply with the 4, because I'm trying to get the whole number, so it is 4.8. Again after decimal it's 8. All right, so now go to the next number 5, which is equal to 6.0. So after decimal it's 0. I will stop here. So yes, let's say you have in the fifth column you have 1.2, you have 2, you have 3. So you use the 5 to change 1.2 into whole number. Make sure you multiply the rest of the numbers with the same number also, because they all together make formula, so they are as a family. So this 2 will change into 2 times 5 will be 10, and this 3 will change into 15 multiplied by 5. 15. This is very important because sometimes kids they focus only on the fractional numbers and they forget to multiply their neighbors numbers too with the same number. Otherwise it will be a mistake, they will not get the correct empirical and molecular formula. So let me show you one more example. Let's say you have in the fifth column you have 1.3, 1.33, let's say. So we know this is an odd number, there is no number which will change this 3 into 0. We will start multiplying with the smallest number 2 till 9. Okay, so as usual, so when I multiply 1.33 with the 2, it will change in 2.66. No, it's a 6. I will go to the next number. If I multiply with the 3, my number is 3.99. Did you see? After decimal, it's a 9. You will stop here. What to do? So it's a 3.9. Round off to the 4. So use a 3 to change this 1.33 into whole number. Make sure you multiply the 3 with the rest of the number of moles 2 in the fifth column, because they all make formula together. I hope it will help you how to determine the empirical formula and eventually the molecular formula. I will upload one more video as a summary for empirical and molecular formula with more example as a PowerPoint slide. Thank you so much, guys.